Welcome to the Introduction to Key Fill video. This video will familiarize you with general key fill concepts utilized by NSA certified end cryptographic units, or ECUs. The concepts covered in this video include red key fill, black key fill, benign keying, benign fill, and benign rekeying. Let's begin by reviewing some key terms and symbols that will be used throughout the key fill video. We'll start with the Electronic Key Management System, also known as EKMS. EKMS consists of 4 tiers. Tier 0 refers to the systems at the NSA facilities in Fort Meade and Finksburg, Maryland. It includes the capability to generate any type of key produced by EKMS. Additionally, Tier 0 acts as the central office of record for accounting transactions for civil agencies and contractors. Tier 0 is sometimes referred to as central facility. The Tier 1 system provides some generation capabilities for electronic key and provides the central office of record functionality for the services. Tier 1 components are located at the primary Tier 1 segments, PT1S, at Fort Huachuca, Arizona, San Antonio, Texas, the extension Tier 1 segment at Mannheim, Germany, and the 5 physical material handling segments, PMHS. The Tier 2 system is at the ComSec account level and consists of the local management device, or LMD, and key processor, or KP. The LMD KP allows the ComSec custodian to perform ordering, accounting, distribution, and even some generation of key material functions. The Tier 3 systems are used to transport keys from the Tier 2 to the ECU, such as a radio or inline network encryptor, also called an INE. It includes modern key fill devices such as the AN-CYZ-10 data transfer device, AN-PYQ-10 simple key loader, and secure DTD 2000 system, or SDS. The KY13, KOI18, and KYX15A are not modern key fill devices, but are Tier 3 systems. Some equipment does not support all key fill techniques. The KYK13, KOI18, and KYX15A are limited in their key fill capabilities. The Automated Communications Engineering Software, or ACES, is another system outside of EKMS that provides some key management functionality. The details of what ACES provides will be described later during the appropriate key fill scenario. Key can be delivered to the ECU in different formats. Red key is unencrypted key. Black key is key that has been encrypted through an approved means. Encryption of key material is sometimes referred to as wrapping. Decryption is sometimes referred to as unwrapping. Benign key is a special form of encrypted key that is wrapped using keys derived from a FIREFLY exchange. Keys and other associated terminology have various purposes depending on the ECU they are supporting. Some examples include traffic encryption keys, or TECs, are used to encrypt traffic passed over point-to-point or point-to-multipoint links. Key encryption keys, or KEKs, are used with an encryption algorithm to secure key material during distribution and/or storage. KEKs are sometimes used by the LMD KP to wrap other keys for distribution so that the key remains encrypted all the way to the ECU where it is unwrapped. Transfer key encryption keys, or TR KEKs, are a special type of KEK. TR KEKs are typically filled into a modern key fill device such as the DTD or SKL. The TR KEK is used by the LMD KP to encrypt keys for distribution to the modern key fill device. The KFD decrypts the keys wrapped by the TR KEK and fills them into the ECU in unencrypted form. FIREFLY vector sets are the key material loaded from EKMS into an ECU to perform a FIREFLY exchange with another ECU. The information passed during a FIREFLY exchange is called FIREFLY credentials. The result of the exchange is a key known only to the two parties participating in the exchange. That key can be used either as a TEK or a KEK. FIREFLY vector sets can be operational or seed. Operational vector sets are used to establish a FIREFLY exchange between two ECUs. Seed vector sets are used to establish a FIREFLY exchange between the ECU using the seed vector set and an ECU at tier 0. This allows an operational vector set to be delivered securely and replace the seed vector set. Let's explore some key fill scenarios. Meet Alice. Alice will be the ComSec custodian that operates the Tier 2 LMDKP. Some ComSec custodians may or may not use ACEs, but for our purposes, Alice is also the ACEs operator. This is Eve. Eve will play the role of the key fill device operator and key fill device. Bob and Charles will play the ECU operators and ECUs. For these scenarios, assume that the key that needs to be ordered and stored at the ComSec account for distribution has already been obtained. Let's look at the different ways that key is delivered to ECUs. Let's start with the two methods for red key fill. Both will result in delivery of unencrypted, red, key material to the ECU. In the first method, Alice gives red key to Eve. Eve then takes that key and gives it to Bob. In the second method, Alice will have to generate a TR KEK. The TR KEK is used to wrap the key we are ultimately delivering to Bob. A copy of the TR KEK is given to Eve to use later. The TR KEK wrapped key is also given to Eve. When Eve has both the TR KEK and the TR KEK wrapped key, she can go to Bob. When she arrives, Eve uses the TR KEK to unwrap the key for Bob. She then takes the unwrapped key and gives that to Bob. The same TR KEK can be used for later transactions with Bob or with Charles. Current fill devices that support TR KEK usage include the DTD, SKL, and SDS. This next scenario covers black key fill using an ECU KEK. The end goal of black key fill is to deliver a black key package to Bob along with the KEK Bob needs to unwrap the black package. Alice starts the process by generating a TR KEK and giving a copy to Eve. She may also generate a KEK if she does not have one available that was ordered previously. The KEK is then used to wrap the keys that Bob needs. Alice then uses the ACES workstation to get the resulting encrypted key into a format that Eve can carry. Alice then wraps the KEK using the TR KEK. Alice then gives both wrapped keys to Eve. Eve is then able to use her copy of the TR KEK to unwrap the KEK and give it to Bob. Eve also gives the still wrapped black key package to Bob. Bob is then able to use the KEK to unwrap the black key package and expose the key that he needs. Like the TR KEK in red key fill, the KEK can be used multiple times. Additionally, policy may require the black key and the red KEK to be in separate fill devices. Let's turn our attention to benign keying. The purpose of benign keying is to securely load operational FIREFLY vector sets into a cryptographic device. This scenario will only describe how benign keying is accomplished for an ECU. Once that is understood, we can describe what is different in how the KP gets its operational FIREFLY vector set. To start this process, Alice will generate a TR KEK. She will then use this TR KEK to wrap a seed FIREFLY vector set that Bob will use to get his operational FIREFLY vector set. Alice then gives the TR KEK wrapped seed FIREFLY vector set and the red TR KEK to Eve. At this time, Alice can also give Eve a credential request for Bob to respond to. Eve takes this material to Bob. Eve unwraps the seed FIREFLY vector set using the TR KEK. She then gives the red seed FIREFLY vector set to Bob. This is the only point at which key material is available in read form. Eve then gives Bob the request for his credentials. Bob uses the seed FIREFLY vector set to generate his credentials and gives a copy of his credentials to Eve. Eve then takes the copy of Bob's credentials back to Alice. When Eve gives Bob's credentials to Alice, Eve also gives Alice any audit data she has. Alice then places Bob's credentials in a rekey message and forwards it to Tier 0. Tier 0 validates Bob's credentials and ensures that Bob's seed FIREFLY vector set has not already been used. Tier 0 generates an operational FIREFLY vector set. Tier 0 then generates its credentials. It then uses its credentials, seed FIREFLY vector set, and Bob's credentials to generate a cooperatively generated KEK. It then uses the cooperatively generated KEK to wrap the operational FIREFLY vector set for Bob. Tier 0 sends the wrapped operational FIREFLY vector set and Tier 0's credentials to Alice. Alice forwards this information to Eve, who in turn forwards it to Bob. Bob then uses his credentials, seed FIREFLY vector set, and the Tier 0 credentials to generate the same cooperatively generated KEK. That KEK is then used to unwrap the operational FIREFLY vector set. The seed FIREFLY vector set is then replaced with the operational FIREFLY vector set. Bob then tells Eve whether or not the transaction completed successfully, and Eve relays that information to Alice, thereby completing benign keying of an ECU. The operational FIREFLY vector set is not exposed in read form outside of Bob or Tier 0's control. For delivery of an operational FIREFLY vector set to a KP, the use of a seed key is not required because the mechanism to distribute any key material to the LMD KP is already secured, so only the LMD KP and Tier 0 can expose the key in read form. So, for the KP, Alice would just order and receive material through normal means. The next scenario will show benign fill. In this scenario, we will use benign fill to distribute key to an ECU. To accomplish this, the ECU must have already been benign keyed. To begin the process, Alice generates a credential request for Bob. This credential request is given to Eve, who relays it to Bob. Bob uses the operational FIREFLY vector set delivered in benign keying to generate new credentials. Bob's new credentials are given to Eve to bring back to Alice. When Eve gives the credentials to Alice, she also includes any audit data she has. Alice then uses her operational FIREFLY vector set to generate her credentials. Alice uses her credentials, operational FIREFLY vector set, and Bob's credentials to establish a cooperatively generated KEK. She then uses the cooperatively generated KEK to wrap the key that Bob needs. Alice then gives the wrapped key and her credentials to Eve to relay to Bob. Bob can then use his credentials, operational FIREFLY vector set, and Alice's credentials to establish the same cooperatively generated KEK. This KEK is then used to unwrap the key that Bob needs. Bob then tells Eve whether or not the transfer completed successfully. Eve then lets Alice know, and again, gives Alice any audit data she has. There are multiple variations on benign fill, including full FIREFLY exchange, half FIREFLY exchange, stored kek, common kek, and stored common kek. The type of key that is delivered with each FIREFLY exchange and how the FIREFLY exchange is accomplished determines the method of benign fill. Full FIREFLY requires the benign fill scenario described previously to occur each time new keys need to be distributed to the ECU for use. Half FIREFLY allows Bob's credentials to be stored by Alice and Bob. Alice generates new credentials and uses the same copy of Bob's credentials for each key delivery. This allows for a new cooperatively generated kek to be used for each key distribution, but only allows one side of the FIREFLY exchange to participate in providing new material. Stored kek allows Alice and Bob to use the same cooperatively generated kek for each subsequent key distribution for benign fill. Common kek gives benefits when multiple entities, Bob and Charles, need to get the same key from benign fill. Both Bob and Charles provide credentials to the LMD. Alice wraps the keys for delivery to Bob and Charles using a common kek that she ordered through EKMS. Alice then generates one set of credentials for herself and uses this to generate two cooperatively generated keks, one for Bob and one for Charles. The cooperatively generated keks are then used to wrap the common kek for Bob and Charles. Alice's credentials, the uniquely wrapped common kek, and the common kek wrapped keys are then distributed to Bob and Charles. Bob only gets his uniquely wrapped common kek, and Charles only gets his uniquely wrapped common kek. This reduces the number of credentials needed to be stored for distribution, since Alice only generates one set of credentials. The detriment of this situation is that each common kek can only be used once. Each subsequent distribution of key to Bob and Charles will require a new common kek and new credentials for Alice. Bob and Charles will use the same credentials. Stored common kek is similar to common kek in that the first key delivery occurs in the same fashion, but the common kek is stored. That allows the common kek to be reused for subsequent key deliveries. This way, only the new key material wrapped in the common kek needs to be sent to Bob and Charles. The next scenario is called benign rekey. Like all other key material, FIREFLY vector sets are only valid for a specific period of time. Benign rekey is used to distribute new operational FIREFLY vector sets to ECUs without having to go through delivery of seed and converting that to operational material. To start this process, Alice generates a credential request for Bob that is specifically marked for rekey use. This request is given to Eve to relay to Bob. When Bob gets the request, he generates his credentials using his operational FIREFLY vector set. Bob then gives a copy of the credentials to Eve to take to Alice. When Alice gets them from Eve, she formats a rekey request message and includes Bob's credentials and sends it to Tier 0. Tier 0 validates the credentials and ensures that they have not been previously rekeyed. Tier 0 can then generate a new operational FIREFLY vector set for Bob. It then generates its credentials from its operational FIREFLY vector set. It then generates a cooperatively generated kek from its credentials, operational FIREFLY vector set, and Bob's credentials. The cooperatively generated kek is then used to wrap the new operational FIREFLY vector set for Bob. The wrapped new operational FIREFLY vector set and Tier 0 credentials are sent to Alice. Alice gives this to Eve to give to Bob. Bob is then able to use his credentials, operational FIREFLY vector set, and Tier 0's credentials to generate the same cooperatively generated kek. That kek is then used to unwrap the new operational FIREFLY vector set. If this is successful, Bob replaces his old vector set with the new one and tells Eve, who in turn tells Alice of the success.